So if we now consider the problem of the co-elution of a matrix effect of compounds that will generate matrix effects in the ionization source of your LCMS system, you have to look at this in several ways. Which compounds can actually create matrix effects in LCMS? This would be the phospholipids, this would be the proteins, or the salts that can actually co-elute. The salts and proteins removal, that's not challenging, that's easy. Salt removal, protein precipitation, these are things that we can handle easily. The overlap with the phospholipids, the co-eluting phospholipids, can be particularly challenging. Because if you have experience with phospholipid analysis, you will actually find that they tend to be extremely retained in conventional reverse phase LC analysis. So this is a bit of an issue with those compounds, and you have to take special precautions, like use extremely strong gradients to get them off the column, and usually this is not being done. So what happens? Phospholipids stay on the column, and they can co-elute during the next analysis, or the third or the fourth analysis, and they will interfere with your compounds you want to quantitate. Your peaks will be smaller, the peak areas will be smaller than what they should be, and therefore you have quantitative issues. So the only solution that we can, there are two possible solutions that we can actually define to solve that problem. Either you get rid of the phospholipids, we remove the phospholipids, or you improve the ionization efficiency of your system. So the ionization efficiency of the ionization sources in mass spectrometry, you can improve this by infusing much smaller flow rates of mobile phases, by using narrower columns, using micro LC type columns, nano LC type columns. The problem, however, is that these systems and these are really not suitable to work in a regulated environment, in an environment where you have to quantitate with a high degree of reliability. So at the moment, with conventional HPLC, which are the workhorse, or conventional UHPLC, which are the workhorse machines in the pharmaceutical environment, you have to remove your phospholipids, therefore, before your analysis via a type of sample preparation approach. And what is the easiest form of sample preparation, which can also be automated, which is therefore used on a broad scale today? That would be a solid phase type of extraction approach. And there has been some research on that point. If you look around, you will find that some vendors have been developing particular types of solid phase extraction removal cartridges for phospholipid removal. However, there are some drawbacks in terms of, for example, in terms of analyte recovery. If you some of the existing commercial cartridges, you will find that basically the pharmaceutical that you recover, that you actually only recover a fraction of that, which is a problem in terms of overall sensitivity of your methodology. There are also sometimes still problems with some phospholipid breakthrough through the SPE cartridges, and therefore we decided to investigate the possibilities if an alternative separation mechanism could not be developed to remove phospholipids via an SPE type of approach. And when you then look in the literature and you look at how the phosphate group or phosphate-containing organic molecules are being retained in HPLC, you will fairly quickly see that the HELIC approach, the hydrophilic interaction liquid chromatography approach, often encounters severe retention of phosphate-containing organic molecules. And so this was exactly our entry point for this particular study, because we wanted to have this severe retention of phosphate-containing compounds. And so therefore, the idea was to develop first an HPLC type, a HELIC type chromatogram, where we look at the phospholipids and the pharmaceutical compounds we want to look at, or at the metabolites thereof, and see how the retention is. And when you do this combined analysis of both, you will see that the phospholipids tend to be much retained, pharmaceutical compounds tend to be less retained, or medium, experience a medium and intermediate retention. But what was then particularly interesting was that actually when we started modifying the acetonitrile, when we started modifying the organic phase to mixed acetonitrile acetone and even to pure acetone phases, that the retention of the phospholipids was increasing even much more. It was increasing to a tremendous extent, while the pharmaceutical, all the small metabolites, were eluting much earlier. And when you have such a tremendous large differences in retention between these two solutes, you essentially have all the ingredients for a very successful SPE procedure. So the next step is then you make a small cartridge containing the same stationary phase as in your helix separation, and you apply the same separation conditions. And there you actually can have an excellent separation tool to remove phospholipids from biological matrices.